All right, so we're gonna start now. Preferably you need a piece of paper or a printer and a pen. So we're gonna start off with practice for UIL, and then we're gonna go over a few concepts, and then we're gonna do some more practice where we can have a Q&A. And if you don't have a printer, that's fine. You can just do the problems on a piece of paper. Okay, so in a typical UIL or TMSA number, since you have 80 problems in 10 minutes, you can't have any calculations on paper or calculators, and all work you do has to be done mentally. You get 5 problems for correct and and you lose 4 points if you skip any of them or if you miss any of them until the last problem you do. Problems marked with an asterisk means that you only need to be within 5%. You can't cross out answers and write out a new one, and if you make a mistake, you just have to accept it. You also have to use a pen, and that's pretty much the rules for this test, and we're gonna try and give you a crash course. Okay, so send this link out in chat. You have 2 minutes to get prepared, and yeah, that's what we're gonna do first. Okay, so you have 2 minutes to print it out, get ready. Don't start it yet. Okay, time's up. Hopefully you've printed out everything and you have 10 minutes to do the test, starting in 3, 2, 1. Okay, so what we've done is we've gone over this and now we're about to do a few examples. So if you did 27 times 19, you know that 7 times 9 is 63. So the units digit is 3. Now you have 6 carry over. 2 times 9 is 18 plus 7, 25. And now once you add the 6 carry over, you know that the tens digit is now 1. Now you have 3 carry over. 2 times 1. And then you add the 3. Okay, so now we're going to do some more practice. I think I already gave you the answer to the first question, but the rest I can do. Okay, so the answers are now on screen. You can check all of them. If you want me to go slower, tell me. If you want me to go faster, also tell me. And try not to use tricks like 20 times 48 minus 48. Right now we're just trying to do arbitrarily 2-digit by 2 digits. Don't use, try not to use any other tricks. Okay. So now we're gonna do multiplying by 25. And this is going to be one of the tricks that appears often. So try doing 18 times 25 by using the previous method of we can get 450, but we have a much simpler way too. Because we know that 25 equals to 100 over 4, we can write 18 times 25 as 18 divided by 4 times 100 by the commutative property of multiplication. And then you do it that way. So try to do it like that. Oh, and also no need to message me the answers to the practice questions. Okay, so real quick, we're gonna We're going to go over the 2-digit by 2-digit again. If it'll load. That's the answer to the questions, the multiplying by 25 questions. Right, so you have 27 times 19, and the way you do this in your head is you first multiply the ones digits. And this is using the property of FOIL. So, that 7 times 9 is 63. You should have known that from your times table. And then you add the products of the tens and units digits of the different numbers. So you take the tens digit from the first number, which is 2, times the units digit of the second number, which is 9. That's 18. And then same thing again, 7 times 1. And now that you add them up, you get 25. And then remember how 7 times 9 was 63 from the previous one? So now you add 25 plus 6, which is 31. And 2 times 1, 513. And that's how you do 2-digit by 2 digits in your head. You don't want to use paper or a calculator in these number sense tests because that's not allowed. So let's try one with, how about this one? 17 times 29. So sometimes, wait, let's try, which one haven't we? 27 times 74. 4 times 4 is 16. You have a tens digit as a 1. 2 times 4 is 8, plus 4 times 7 is 20. 28 plus 8, 36. And then you add the 1 from the 16. And then 1776. Okay, so hopefully that's clear. If it's not, you can message me. But that's typically how you do 2 digits by 2 digits. And multiplying by 25, we have also gone over that now. So 25 times 27, you know that 27 divided by 4 is 6.75. And then you multiply that by 100 to get 675. 72 times 25, you know that 72 over 4 is 18. 18 times 100, 1800, and then that's what you do for the rest of them. Okay, so the same thing goes for multiplying by 50. You divide by 2 first, but then you multiply by 100. So we're going to skip over multiplying by 50, but now we're going to head to multiplying by 99. So this is similar to the thing that I think one of y'all did. You did 48 times 19. You changed it into 48 times 20 minus 48. But for this one, we're going to do it with 99. 99's pretty annoying to multiply by, so we're going to do this trick. 84 times 99 equals to 8400 minus 84. And we have a few more problems. So I should have mentioned this at the beginning, but a lot of this is going to be example based because the best way to get good at number sense is to practice. Knowing all these tricks help, but you have to know how to do them quickly too. If any of this is confusing or if I'm going too fast, you can tell me. And remember, do all of these mentally. Okay. Those are the solutions. Does anybody have any questions about multiplying by 99? Okay. So now we're going to multiply numbers close to but less than 100, say 98 times 96. We could solve that using our method in 1.1, but we have simpler ways. First, we find the difference from 100 from both of these numbers. 100 minus 98 equals to 2. 100 minus 96 equals to 4. And now we multiply these numbers to get the units digit. Remember to use both the tens and units digit for this step. So 2 times 4 is 8. And you know that the number will end in something 08. And now we subtract the difference from one number to get the other number. So the difference from 96 was 4 right there. And now we subtract 4 from 98. So now we know that the answer is 9,408. So someone wants me to go over remainders, and I'll do that at the end. Okay, so let's try this out. 93 times 91, 89 times 98, 95 times 92, 99 times 97. Don't use the trick from 1.1. Try to use this new multiplying numbers close to but less than 100. Yeah, I don't think we have a remainder section, so I'll add that on to the end. Okay, so 93 times 91, you know that the difference from 93 is 7, the difference from 91 is 9, 7 times 9 is 63, 93, 7, and then 91 minus 7 is 84. And you just do something like that for the rest of them. Check for your answers. Anybody have any questions? Okay, so now we're going to multiply numbers close to but greater than 100. So like 103 times 108. We do something pretty similar to the multiply numbers close to but less than 100. We do 3 times 8 for the tens and units place. And then we add 3 and 8 to get 11. And lastly, we add a 1 in front to get 11,124. Everyone understand? Okay. 102 times 105. Few problems. Okay. So 102 times 105, 2 times 5 is 10. You add the 2 and the 5 to get 07, and then you put a 1 in front. For 109 times 103, you multiply 9 by 3 to get 27. You add 09 and 03 to get 12, and you put a 1 in front again. So 112 times 115 might be a bit tricky because for this one you have to carry over. So 12 times 5 you get as 180. And if you don't know how to do 12 times 15, you could do 12 times 15 equals to 6 times 3, and then you get 180. But you only get to put the 80 in the tens and units digits. So now you have a 1 left over. And you add that 1 to 12 plus 15, you get 28. And then lastly, you put a 1 in front. So let's go on. Unless if any of y'all have questions. And now we're going to multiply a number that's close to but less than 100 with a number close to but greater than 100. So say 96 times 103. Say the number less is 100 minus 8, and the number more is 100 plus b. The tens and units digit is going to be 100 minus AB. That's going to be the tens and the units digit. For the thousands and that should say hundreds digit. The thousands and the hundreds digit should be 100 plus b minus a minus 1. And 100 plus b is just the first number. So say 96 times 103. 100 minus 4 times 3 is 88. So those will be the rightmost two digits. For the leftmost two digits, you would do 103 minus 4 minus 1. So our answer would be 9,888. Does anybody want me to go over how we get this formula? It's a little bit of FOIL. Okay, if not, then y'all can just go ahead and apply it. 105 times 75, 103 times 74, 108 times 99, and 110 times 93. A few of these have, actually, 3 of these have certain other properties you can use to find the product. So see if you can do those. See if you can find the product in 2 ways, from the first one, the third one, and the fourth one. And if you do find them, message me how you got the 2 ways. Okay, let's try this out. I may not have explained it well. So 105 times 95. First off, we have A equals to 5, B equals to 5. So 100 minus AB should be 75. And then we have 5 here, and you know that's 100. Our uh, our trick here tells us that it should be the big number minus the difference, and then minus another one. So 105 minus 5 minus 1, you get 99.75. Here we have 3 times 6, 18. 100 minus 18, we would get 82. 103 minus 6, 97. And then we have to subtract another one, 96. 108 times 99, we have 8 times 1, 08. 100 minus 08, 92. And then we have 108 minus 1 minus 1, 106. And last up for this one, we have 10 times 7, 70. We have a 30. 10 minus 7 minus 1, 102. So I said that you had 3 other ways to do this one, and this one. So for this one, we don't have a slide on it. So if we have time at the end, I'll go over the other way to do it. It's called difference of squares. This one, you could have done the 99 method. And for this one, well, that's what we're just about to go on to. So let's go. 23 times 11. Well, you know that the unit digit is 3 because 3 times 1 is 3. The tens digit is 5 because you add 2 and 3, which is 5. And the hundreds digit is 2. So in other words, for each digit in the product, it's the sum of the adjacent 2 digits from the number that's not 11. So 92 times 11, you would write down 2, and then you have 9 plus 2, which is 11, so you would write down 1, and then you have 9, and you have the 1 carry over to get 1012. So once you're done, tell me. Okay, sorry if I've missed your answers, but I think most of y'all got it. So 92 times 11, 78 times 11. Okay, let's go. Let's see if you can do this problem using the new method. So 110 times 93, you would 110 is just 10 times 11, so you'd add a 0. 11 times 93, 3, and then 2, 10. You know how to do it now. Okay. Now multiplying by 111. So it's really similar to multiplying by 11, but now you add 3 adjacent numbers. So for example, to find 327 times 111, we know that the units digit is 7. The tens would be 2 plus 7, 9. Hundreds digit would be 3 plus 2 plus 7 to get 12. So the hundreds digit would be 2, and we have 1 as a carryover. Thousands digit would be 3 plus 2, 5, 6. 10,000s digit would be 3, and that's our answer. The recording will probably be posted on the website, and as well, if you'd like the slides, you can message me. You can email me at myan3459@gmail.com. Okay, so we have a few more practices. The first one you can do either the method you can use either one of the methods, multiplying by 11 or 111. If y'all just joined, you probably thought it was CST 6:30. He started an hour earlier, so right now we're just doing 111 times 11. If you'd like to see what we've done before, I have the slides and there's also a recording, but yeah. Um, Sorry if I'm not responding to your messages. But I think I think some of y'all got it. So we'll work this one out together. So if you just joined, we've gone over multiplying by 2 digits, multiplying by numbers close to 100, multiplying by 11 and 111. And we've also done a practice set. So right now we're going over to multiplying by 111. That's what all of these problems have in common. So 11 times 111. First off, you'd have a 1. Then you add these 2 digits. 2. I guess an easier way to think about this would be 0, 0, 1, 1. So first you would have 1. Then you would have 1, 1 to get 2. Then you would add these ones, which would still be 2. And then you add these ones, which would be 1. And that's all. For this next one, I guess we could do the same thing again. you have 3. Then you add 2 and 3 like that to get 5. Then you add those again to get 5. And last up, you have 2. So now we're going to go on to 3 digits. So you have 8 to get the first one. You have 8 plus 3, and you get 11. So you put the tens digit as 1, and now you have a 1 carryover. Now you add those again, you get 13. And then you add the carryover to get 14. You would put 4 in the hundreds digit, 2 and 3, 5, 6, and then 2 as the last one. That's pretty much what you do for all of them. It starts off like 1, and it goes on to 2, and then you add those, then you add those, then you add those, and then it fades out. Okay. Now let's multiply by 37. So try to do this one. If you know the trick, go ahead and use it. If you don't, use the first method we talked about. And remember, if you're new, because you just joined, we're doing numbers since it's all mental math. You can't use paper calculations or a calculating device. So we're going over a few tricks to do all these problems in your head. And if at any time I'm going too fast or too slow, then go ahead and tell me. Okay, so if you did the original problem, you should have gotten 444. And the special thing about this number is that 37 is when 11 divided by 3. So you know that it's like the same trick we did with 25 and 50. 27 times 37 equals to 12 over 3 times 111. 4 times 11, 444. So let's do some practice. And if you are new here, I'll send you the slides. The slides are posted in chat. So if you missed the first part of the meeting, you can go ahead and look it up there. We are currently on 9.3, slide 33. And if anything I said was unclear, you can also look at the slides. Okay. So 27 times 37, 9 times 111, 999. 213 times 37, 71 times 111, 7,881. And yeah, that's the trick for multiplying by 37. They should always give you a number that's divisible by 3 there. If they don't, then you should probably just use the normal method. But yeah, let's go on. Okay, so we're gonna go over triangular numbers and then we'll go over polygonal numbers, and lastly, we'll go over any questions that y'all have had. So you might see these kinds of problems. Find the fourth triangular number. Let's define T1 as the first triangular number, Tn as the nth triangular number, that they'll usually be asking you to find. So Tn equals to n plus 1 times n divided by 2. So say he asks, find the fourth triangular number, you would plug it into the formula. 4 times 5 divided by 2, 10. So now let's look at the geometric interpretation. So T of n equals to n plus 1 times n divided by 2, which is what we've just said, and now we're going to look at y. So T of 1 equals to 1 if we plug it into our formula. T of 2 equals to 3. And essentially what a triangular number is, it's the nth triangular number is a triangle made of n rows in this pattern. And the way we get that formula is T of 1 has 1 number in its first row. T of 2 has 2 numbers in its second row. So each triangular number, you're adding n balls to the bottom of the triangle. And that's our formula. And that's how you find the sum of a arithmetic sequence. Okay. So I've put the formula up there, and find out the 2 triangular numbers. Okay. So the fifth triangular number, 5 times 6 divided by 2, 15, 10 times 11 divided by 2, 55. So triangular numbers are generally more simple compared to what we're about to go on to, which are polygonal numbers. According to Wikipedia, which you probably shouldn't use in school, but it's occasionally good. In mathematics, a polygonal number is a number represented by dots or pebbles arranged in the shape of a regular polygon. For example, the nth polygonal number simply means the number of dots in that specific polygon with side lengths of n dots. For example, the second polygonal number, let's look at this image. Each side has 2. It have 6 dots, 1, 2, 3, 4, 5, 6. If S is the number of sides in a polygon, the formula for the nth esconal number P would be S minus 2 times n minus 1 over 2 plus n. And I don't think we're going to go over this proof. Okay. That's my bad. Find the 6th pentagonal number. Find the 10th decagonal number. Find the 18th square number. For this one, you might want to use the geometric interpretation. And the 3rd heptagonal number. Okay, so the 6th pentagonal number, 5 minus 3, you get, 5 minus 2, you get 3, times 6 times 5 over 2 plus 6. The 10th decagonal number, 10 minus 2 is 8, times 10 times 9, divide by 2 plus 10. So an 18th square number, if you use the geometric interpretation provided by Wikipedia, that would be a square with 18 dots on each side. And 18 squared is 324. And the 3rd heptagonal number, you get as 5 times 3 times 2 over 2 plus 3, 18. So Roman numerals are kind of a memorization thing. Like you absolutely have to memorize them. So I'm not gonna go over them for the sake of time. But if you're curious, I'll post the slides again at the end. Okay, so we're gonna go over a few notes, and then lastly, I'm gonna go over a few questions that y'all had. So practice, make sure why these formulas work. If you don't if you don't understand, go ahead and ask. Something that you just have to memorize for number senses. The squares of 1 to 40, the cubes of 1 to 20, to know notations, to know what hexagonal, decagonal, dodecagon, you have to know what they mean. So the two big ones are probably to memorize the squares and cubes and to know the tricks. And once you do those, all you have to do is practice. So now we're gonna go over to the questions y'all had about the test from the beginning of the class. Okay, so the first question I see right now is question 54. So it's asking for 6C2. And this is a notation. You have to know the notation for this one. The C here means choose. So really it should be read as 6 choose 2. And so this is 6 n choose m is n factorial divided by m factorial time divided by, again, by n minus m factorial. So let's do this. So n 6 choose 2. It really means that you have 2 items choosing from 6. Choosing is different from ordering in the sense that it doesn't matter how you choose them. So you have 10 students in your class. Your teacher wants to pick 5 of them for a student council. It would be 10 choose 5. You're picking 5 people from a class of 10, and all jobs in the student council are the same. And that's what really distinguishes it from when order matters. So say you have 10 students again, and your teacher wants to pick a president and a vice president. In this case, 10 choose 2 would be incorrect because a vice president is different from a president. So the real answer would be 10 times 9. So let's go over how you would solve a choosing question. I guess I'll try and give you the way this way. Okay, so you have 6 people. Do you know what factorial is? AKA 5 factorial. Do y'all know what that is? Okay. You have 6 choose 2. So one way to think about the formula for choosing is that you're first permuting these 6, which would be 6 factorial. You have B, C, A, E, F, E, G. Say that's just a random permutation. And now you want to pick 2 of them. So say no matter what permutation you get, you always pick the first 2. Well, the order of these 2 doesn't really matter. So you divide by 2 factorial. But the order of the people that you didn't pick also doesn't matter. So you divide by another 4 factorial. And that's essentially how you get the formula as n choose m equals to n factorial divided by n factorial times n minus m factorial. So taking this formula into account, 6 choose 2 would be 6 factorial over 2 factorial over 4 factorial. And that would be the answer to question 54. Okay. Let's go to question 8. So we have We have the trick for this one. 36 times 25. You divide 36 by 4 and you multiply by 100. Let me see if I can find it. Yep. You divide 36 by 25 and you multiply by 100. Okay. Right now we have some more problems to go over. Question 27. Oh, okay. So this is what I said was so important about memorizing the cubes from 1 to 20, because questions like this will show up. The cube root of that is 15. I guess even if you didn't know the cube root of that, you could know 10 cubed is 1,000, 20 cubed is 8,000. This number is in between those, and the only way you can have 5 as its last digit is if it was 15. And then 15 squared, if you didn't memorize the squares, you could do the trick we've gone over, but again, you should memorize those. For this one, I suppose you could. This is one of those asterisk questions, which means that you can pretty much estimate them. So I suppose you could bump this 23 up to a 25. You could do that, or you could just cut off these two. You would do something like 23 times 4 is 92, and you have 98, so maybe like 4,400 would be pretty close, because you only need to be within plus or minus 5%. So it's always up to you on how you estimate them. But again, not every question is you need to do. As long as you can get the questions after, you should be good. Question 3. Okay, so for this one, you need to know a theorem called Vieta's. I probably... Okay, let's see if I can go over in the next 5 minutes. So this is called Vieta's. Essentially, what it is the sum of the roots would be the first number divided by the coefficient of the first number and the the additive reciprocal of that. So -3 over 1 and times -1. The sum of the roots would be 3. The product of the roots would be the last one, which would be 15 in this case, divided by the first one times -1. The issue is I only really explain it in the case of cubic functions. So I would recommend you looking up Vieta's or asking your teacher about it, because it depends on the whether the power, the largest power is even or odd, and that determines on how you use it. Why is it question 36? Okay, so assuming you know what via this is, and if you still don't worry. Just ask one of your teachers about it. You don't need to know it now. But the product would be -15, and the sum would be +3, because -3 divided by 1 times -1, the sum is 3. The product, negative, positive, negative, -15. Sum equals 3. And you know what? You're right. The answer to question 36 should be negative. Negative. Wait. Yeah, it should be 18. Yep, my bad. The answer should be 18. Because you have 3 minus -15. Okay, let's go on. Oh, that's actually all of the questions for the test we did at the beginning. Okay, somebody asked me at the beginning for difference of squares. Wait, no, asked for remainders. So I think the one remainder question on the test was this one, 1023 divided by 9. And this is one of the tricks that you should probably know. So dividing tricks. Dividing by 2 is simple. Dividing by 3 is you add all of the digits up, and whatever the remainder of that is in mode 3, that would be your answer. So say you have 5, 2, 3, 4, 2. You add them up to get 16. And 16's remainder when divided by 3 is 1. That's one of the tricks for dividing by 3. Dividing by 4, you only have to look at the last 2 digits. Dividing by 5, you look at the last digit. Dividing by 6, you both look at when it's divided by 2 and when it's divided by 3. 7, 7's a little bit more tricky. So what you do is you double the last digit to, so in this example, it would be 8. You subtract it from the rest of the digits. So 233 minus 8, 225. And again, maybe you could solve it from here, but if you didn't want to, 22 minus 5 times 2, 10, 12. So it would be 5. 8, you look at the last 3 digits, and 9, which is what the question is asking, you do the exact same thing as for 3, in the sense that you add the digits, and yeah, so the answer would be 6. Okay, does anybody else have any questions about anything that we've covered today? Okay, I'm gonna send out the slideshow. Okay, if you're interested, I can stay behind like a few minutes to go over Vietas as proof, but other than that, you're all free to go. See ya. Okay, so before we go over to Vietas, again, you can ask a few more questions. Let's see. Vietas. So, we're gonna start off with a claim that all polynomials with real coefficients can be written as a product of its roots, I guess. So like ax to the n plus, well, I wish I could write this out in a different way, but a of n times x to the n plus a of n minus 1 times x to the n minus 1, etc., times a of 0 times x to the 0, which would also just be 1. We're going to claim that that can be written as a of n times x minus r1 times x minus r2 times x minus r3 times x minus r of n. So the roots may not necessarily be real. They could be imaginary numbers like I2 plus 3i, but we're not gonna really care about that for now. Okay, so say you want to find, so we've written out this as this now, right? Now let's expand this. So once you expand this, you get equals to a of n times x to the power of n. Now this term is exactly the same as this term, but now we're gonna go and do something interesting. The next term will be a of n times x to the power of n minus 1 times negative r1 minus r2 minus r3 minus rn. And this comes from just expanding it, I guess, because you're picking n minus 1 x's. So say you multiply all of the x's from this one, from these, that would be x to the n minus 1. And then you multiply by negative r sub a. And you do that for all of them. And that's what you get for the second term. This would be the third term. So we're picking two of the roots to multiply. And it would just continue on and on. So lastly, you would be multiplying all of the roots. Let's see it first. Lastly, you would have all of the roots multiplied. And the sign of this depends on how many roots you multiply, because all of these have a negative sign in front of them. So if n is even, this would be even. If n is odd, it would be negative. So then you compare these terms, and because of a certain property of polynomials, you know that this has to be equal to this. In other words, a of n times the negative sum is a of n minus 1. So then, you know that a of n minus 1 divided by a of n equals to the negative sum. So the sum is the negative of the second coefficient, then divided by all of that. And same thing goes for the product and the sum of the products, and so on and so on. So that's Fietas in a nutshell. Any questions? All right, well then, see ya.